Hello people, I'm going to give you some tips on how to answer exam questions that have minerals that you need to identify within them, because I know some of you had difficulties with this in mock. The main thing that you will have in an exam that will help you with this is your mineral ID sheet, mineral data sheet as it's called on here. The thing that you can use as well while you're practicing these exam questions is a textbook or your notes. So I'm going to go through how to, step by steps really, how to answer the question. So there's 3 steps to start off with. The first step is what do you know about the rock type that the minerals are contained within. So in this particular question, we were given a picture of rock A. It's a photomicrograph, so it's been taken underneath the microscope of a thin section. And you can see that there are named minerals on here, hornblende and quartz, which is forming a ground mass. Mineral X, we've got that cut through this way and cut through this way. And mineral Y, a large mineral in this case, over 1 centimetre in size, is also identified there. So that's the first part of it. The second part is what do you know about mineral X? It gives you some data. It's black, it flakes into thin flexible sheets. And again, what do you know about mineral Y? It's pink and it's split along 2 planes at 90 degrees. So let's go through this then. So rock type, first of all, what does it look like? It's either going to be igneous, sedimentary or metamorphic, and the examiner in this particular question was very useful because they put rock B and rock C on there as well for you to contrast. And you can see that rock A is crystalline. It's got a ground mass of quartz and it's got interlocking crystals. Rock C has also got interlocking crystals as well, but they're foliated. They seem to have some sort of flow pattern to them, which would indicate that rock C has been squashed and it's been metamorphosed, so it's a metamorphic rock. Rock B has got some rounded and sub-rounded grains in it, some subangular grains in it, and it seems to have a matrix of pores and grains. So rock B is sedimentary. Rock A has no foliation and it has no pores or grains. It's crystalline, it's igneous. So, knowing igneous rocks, this is something we need to learn. So we know that there are different types of igneous rocks. Here's some named ones: granite, diorite, gabbro, peridotite. And they're placed in categories that depend on their silica content. They can either be silicic, intermediate, mafic, or ultramafic. And depending on what category of silica they have in them, they have different minerals in them. And they only have those minerals in them. These are the essential minerals within an igneous rock. So you're not going to get in an exam some other mineral, rock-forming mineral like barite or galena within an igneous rock. It's only going to be these guys here. You won't have this in an exam, but you should try and learn as best you can when you're describing igneous rocks what type of minerals are within them. So we can see here in rock A we've got hornblende and quartz, which puts us somewhere over here in the sort of silicic intermediate category. There's hornblende, there's quartz as well. So that means that mineral X and mineral Y are going to be somewhere within here as well. Now what do we know about mineral X? It's black and it flakes into thin, flexible sheets. While we know that aurgite is black, we know also that olivine can appear black, but it's mostly green. We know hornblende is sort of browny black, and biotite mica is also black. So let's have a look now on the mineral ID sheet. Here it is. Now this table should not be memorised, as the examiner tells you, because you get it in the exam. So those things that we've discovered about mineral X is that it's black, so that's a colour. So look down here and find a colour, brown-black. Oh, there's biotite mica, black hornblende, that's good. We've got some ones that are dark grey down here, but they're not in igneous rocks, so ignore them. Let's just look up here. So I'm going to look across here, and I'm going to try and find something that describes flaky crystals. Goodness me, there it is, flaky crystals. Brown-black, biotite mica. We know that is in silicic and intermediate rocks, so mineral X is all likely to be biotite mica. So what about mineral Y then? So we've identified biotite, we know there's quartz, we know there's hornblende. What else could it be? So it's pink, the colour, and it splits with two planes at 90 degrees. That's a cleavage, guys. So you're going to look in cleavage category. So cleavage, here we go. Two good at 90 degrees, two good at 90 degrees, the feldspars. Now there are others. Augite was also two good at 90 degrees, but it's not in silicic rocks, and also it's greenish black in colour, so it can't be augite. Barite is also two good at 90 degrees, and it is white and pink, but it's not in your igneous rocks table, so it's unlikely to be barite. It's much more likely to be one of these, and there we go, pink, orthoclase feldspar. The mineral Y we identify as orthoclase feldspar. As simple as that. Likely igneous minerals that you're going to get if you see an igneous rock are the top number here on the mineral ID sheet. There aren't going to be ones down here, and there won't be ones in the middle here either. Okay. So, if you've got metamorphic rocks, don't worry about this bit up here, that doesn't matter. It's pretty much the similar thing. So you can see that it's got foliation within it, and that's going to give you a clue of what type of metamorphism is taking place here. It's not contact metamorphism because you've got foliation taking place, so it's clearly regional metamorphism. What do you know about mineral X? Well, it's red-brown and scratches the street plate. Mineral Y is pearly in luster and has flat, flaky crystals again. So we know some information about it, and we're going to use our mineral data sheet. But before then, we need to think about what do we know about metamorphic rocks. Well, here are our metamorphic minerals for regional metamorphism. You've got chlorite, chalcopyrite mica, muscovite mica, and biotite mica. They've all got flat plated minerals. We've already established that. And then you've got garnet, staurolite, kyanite, sedimentary, and albite. So let's see if we can work out which of those minerals are going to be within our rock. So here we go. Mineral X is red and it scratches the street plate. So of those ones that we've got, there's chlorite, there's biotite mica, muscovite mica. We haven't got some of the other ones on there. There's chastolite and andalusite, but they're contact metamorphism. So the other ones you don't have to worry about, like sedimentary and kyanite, because they're not on the mineral ID sheet. So it's definitely garnet. It's got a hardness of 6.5 and 7.5. That's why it scratches the street plate. It tells you that on here. And it's red-brown, so it's very clearly mineral X. So if we know mineral X is garnet, we know that it's within the medium range of regional metamorphism. So you can't have chlorite with it. So even though chlorite is the top of mica, it's not going to be there. You can have a little bit of sedimentary, but they're not on the mineral ID sheet. Neither is kyanite or staurolite. So it's going to be one of these three, really. Or it could be plagioclase feldspar, sodium plagioclase feldspar. But it's got flat, flaky crystals and pearly luster. You know that plagioclase feldspar doesn't have that. I'm pretty sure you know which one it's going to be, so let's have a look. Okay, so no, they have crystals that have got good cleavage within them and twin patterns. Here we are, the flaky ones. So it's going to be muscovite or biotite mica. They've both got pearly luster, so it could be either of these really. The examiner's been a little difficult there, so you could put either of those down and say, and would still get that correct for mineral Y. So mineral Y, I put muscovite mica, but it could be a biotite mica equally. Right, the likely metamorphic minerals that you're going to encounter, quartz is always pretty much a safe bet, but feldspar is also in there. micas, and then chlorite, this green mica, chassolite and garnet. And you're very unlikely to come across any other minerals in a metamorphic rock. Sedimentary rocks, well, unfortunately they are a little bit more tricky, and the examiner likes to make them a little bit more tricky in the questions that you're going to answer, because sedimentary rocks come from the weathering and erosion of pre-existing rocks, igneous or metamorphic. So they could contain any mineral that's in an igneous rock or a metamorphic rock. They also might contain other minerals as well. So it's going to be a little bit more tricky to do your identification, but don't panic. Here's a question that was on the mock exam, and lots of you struggled with this one. It says, explain why the mineralogy of the cement would cause the sandstones to weather at different rates. You may refer to the mineral data sheet. Fine. So marble, that's not sandstone. Slate, that's not sandstone. Granite, it's not sandstone. Oh, sandstones, here they are, D and E. And I've helpfully sketched in the resistance of sandstone with quartz cement. And there's the cement, calcite and quartz. So you have to think to yourself, what do we know about weathering? What types of weathering are going to take place within a graveyard over 100 years? Okay? Well, we know that it could be physical weathering. You know, there could be damage to the gravestone through freeze thaw. This is probably in Britain, and that could certainly happen. There might be chemical weathering as well. So you might have acid rain, because again, we live in Britain, we burn coal in power stations, and that will create acid rain in the form of sulfur dioxide and nitrous oxides. What do we know about these cements? Calcite and quartz. Well, that's where we have to start looking at the mineral data sheet to find out. So let's have a look at them. Here's quartz. Pick out the things that are going to be resistant or susceptible to weathering. So it doesn't really matter about its luster, it doesn't really matter about its colour, or indeed the shape of its crystals. It doesn't really matter about the density either, but the hardness is a colour. Calcite has a hardness of 3, quartz has a hardness of 7. Also the fracture pattern as well. Things that have no good discernible fracture pattern are difficult to fracture with freeze thaw. Things that have cleavages are much more likely to break off. There's another thing that calcite possesses, and we know if we add acid to it, it effervesces. So it's going to be susceptible to acid rain, whereas quartz is not. So we know that calcite has a hardness of 3, possesses 3 good cleavages, and reacts with acid. Quartz, on the other hand, has a hardness of 7, no cleavage, and is resistant to acid. And that's what the examiner is expecting you to put in here. So you can construct your own answer to this now. Press pause to do it.